It is question number 3. It is a topic from chapter 7. Chapter 7 title was the sampling distribution. So now I can say here's the mean of the mean, and here's the standard deviation of the mean. It's actually the mean of the mean was the same as the mu, which was the population mean, and the standard deviation of the sample mean was the sigma over square root of n. So probably we had the population mean here. It is the mu, and that is the sigma, and also we need a sample size is a 3, that is the n. So we had is everything. So now the mu, the mean of the mean, that is the same as the population mean, 1.20, and the standard deviation of the sample mean will be the sigma is a 0.12 over square root of the sample size, the 3. So it's actually 0.12 over square root of 3, that is 0.06928. How many decimals? You have to answer is 4 decimals. It's 1, 2, 3, 4. So it must be 0.0693 is actually, we have to the rounding. So by this way, we take the mean of the means and the standard deviation of means. In part B, we have a more sample size, so the standard deviation of the sample mean it should be 0.12, but we have a more sample size. Okay, so you can enter the other parts. So let me go to the next page. The next page, it has some problem to see the pictures, but probably let me take this one. Because we had is a more sample size, so the standard deviation will be 0.12 over square root of 12. It will be 0.0346, right? So what I want to say, when we have a more sample size, then the standard deviation is getting smaller. But still, the mean of the mean will be same as the population mean. It does not change, right? But the standard deviation is getting smaller. So it is not clear, the picture here, but in here, you can compare the two distributions. The second one, when we have a more sample size, then we have the smaller the standard deviation. So please is compare the two pictures and take the answer. Okay, and the next one is a part D. The part D is ask us to get the probability. To get the probability is within is a 0.1. Actually, the population mean was the 1.20. So that was the population mean, and it was the same as the mean of the sample means. So now, let me make the the standard, the normal distribution is a mean equal 1.20, and the standard deviation of the sample mean, when now we have the sample size is equal 3, and repeat as with the second example. The sample size is more sample size is a 12, but now in part D, still we have a sample size is equal to 3. So the standard deviation of the sample mean was just a second, I need more space. 0.0693. Okay, so it is the normal distribution for the sample mean, but now we need the percentages within 0.1 kilograms. That means here is a minus 0.1. It's a 0.1. That will be 1.1. And here's the add 0.1 is a 1.3. So we need the probability here. So many times I gave you a map, right? Here's a sample mean, but we had the normal distribution. Yeah, it's now we had a normal distribution, but finally the final destination to get the probability, then in the middle is that we need the z-score. Do you remember that? Right? Yeah. So by the map, we need the z-scores. We need the z-scores at 1.1 and 1.3. So it's a 1.1 minus the mean 1.2 divided by the standard deviation. It's a 0.0693, and the other one should be 1.3 minus 1.2 over is 0.0693 again. So now let me take the first one. The first z-score, z1, is a 1.1 minus 1.2, that is a negative 0.1 over the standard deviation 0.0693. That is the negative 1.443. But most of the time, we need the two decimals for the z-score. So I just take negative 1.44. And the positive one is 1.3 minus 1.2 is a positive 0.1 over the standard deviation 0.0693. Then we have a positive 1.44. So here is a negative 2 point something. So let me go to the next page. The next page. Yeah, it's the next page here. Now the z-score was a negative 1.44, negative 1.01234, right? Yeah. So on the left hand side, there is a probability 0.0749. So let me go back. Yeah, I mean here to the left, there is a 0.0749, and also I need the other one is here, right? So I have to go to positive 1.40 there is only 1.3. So let me go to the next page. Yeah, next page here is a 1.44. Is a 1.401234. To the left at 1.44 there is a 0.9251. 0.9251. So 0.9251. But we need the probability in the middle. So in the middle it must be take the subtraction as a 0.9251 minus 0.0749. The subtraction will be 0.9251 minus 0.0749. I have a 0.8502. Okay, so the probability, what was the question? Is the part D. The question was determine the percentages. Is within, yep, here is a within is a 0.1 kilograms of the population mean 1.2. For the mean, yeah, that is the key point. That is a key point for using the sample mean, the distribution of the sample mean, the mean brain weight, right? Yeah. So now I can say it is 80 85 point, how much was the answer? The answer was is 0.8502. So yeah, two decimals is a point oh, oops, it's a 02, it's a percent. Okay, because of the rounding problem, is you might get is another good answer, but it might be wrong. Yeah, but please email me. I will give you the credit. The second case, we got another standard deviation as not the point 0.0639. I remember when we have a more sample size 12, the standard deviation was a 0.03 something, right? So using another standard deviation, you are going to take another z-score, but still you can take two another probabilities, and just simply take the subtraction, as that would be the probability. It's just in the middle. It's within is a 0.1 kilograms. So you can try the others. Okay, so we tried the number 3. The problem is number 3. For the first one, it was from chapter 7. The title was the sampling distribution for the sample mean. Let me try the next one. The next problem is I chose number 7. I think this one is a number. Oh, here's a number 6. Yeah, I will try to do the number 6. Okay. Let me see, number 6. Okay. I think it is the standard deviation. Determine the probability. Yeah, we need the probability. I think the 555, that is the sample size, and we need the probabilities within 100. Where is the population mean? Yeah, see, I can say it is the sigma, and that is the n. We don't need the population mean. Okay, so let me try. Without the population mean, the mu, but let me try to get the answer. So here's the normal distribution for the sample mean. There's the, just a second. Yeah, here's the key, the mean things, right? So it is a problem for the sample mean. And we don't know how much is the mean of the mean. Is actually the mean of the mean was same as the population mean. But we can take the standard deviation of the mean by the sigma over square root of n. The sigma was given 1250, and the sample size was given is a 550. So when I take the standard deviation, it's a 1250 over square root of 550. So that is the 53. It's a point. It's a 3. Okay. Even though we don't have what is the mean, but the question was what is the probabilities within 100. So now I can say here is the minus the mean of the mean minus 100, and here is the mean of the mean add 100. So it's almost the same problem. We need a probability in the middle. Okay. So now then we need the z-score. Add here and there. But look at this. Even though we don't have the mean, but actually we have to do the mean, the point here, that is the mean minus 100, and then minus the mean again, right? So simply Yeah, we can cancel out. We can cancel out the unknown mean, right? So it's actually the numerator will be negative 10 divided by the standard deviation. So in this problem, even though we don't have the mean, the population mean, but finally we just cancel out the means. So it will be actually is negative 100 is over the standard deviation, 53.3. And the other one is the same thing. The other one will be same. The score here is a mean, add 100 minus the mean again, right? And divided by the 53.3. So without the mean, but still the bigger one is a positive 100 as a divided by the standard deviation 53.3. So let me take the left one is a negative 100 over 53.3. That will be just a second. I'm wrong. Just a second. Negative 100 over 53.3. I have as negative 1.88, 2 decimals. And now it is an even distance. So the right one will be positive 1.88. Okay. Then now what? You have to take the probability to the left at negative 1.88 and the other one at positive 1.88. So let me go to the z table. Where is the z table? Yes, I think the next page. Yes, I'm sorry. Yeah, negative 1.88, negative 1.88, 1.8, 1.8. And the very last one is the 9 and 8. This one, yep, there is a 0.0301. So let me go back. Where was it? Oh my god, I lost. I think here. Yep, I remember there was a 0.0301. Let me try the other one. Actually the 0.0301 is here. And I can say it's not only the left tail, but also the right tail. I mean this one. That is a 0.0301. Does it make sense? Because the normal distribution is symmetrical. So another way, I can take the probability in the middle. How about this one? Is 1 minus twice 0.0301. Why I took the twice? Because I just let me erase. I just erase the left one. And erase means it's a subtraction. It's a 2 the probabilities 0.0301, right? So it's another way. It's as traditionally we take the 2 left tail probabilities and subtraction, right? But the other way is like this way. We can take the probabilities. Let me try. 1 minus twice 0.0301. I have a 0.9398. Can you see the answer here? Right? Yeah, it's a 0.939. Yeah, a little bit different. It's actually, it must be 0.94. But I told you it's because of the rounding problems. Probably. Even is a 0.940 will be the answer. Yeah, you can try, but it's wrong, then email me. I will give you the credit. So number 6 is the same problem, but what was the problem? What was the difference? The sample mean, I mean the mean of the sample mean, I mean the population mean was not given. But still, we can take the 2 z-scores, then we can take the 2 probabilities, or this way, even we can take the probability in the middle. Okay, so it's the same problem, but it's a little bit different format. Okay, so it was the number 6, and now let me go to what's the next? Maybe just a second. Maybe the number 8. Yeah, this one. I mean this one, number 8. Okay, it's a number 8. I think from number 8. It's from number 8. It is from chapter 8. The topic was the confidence interval. So now, in this problem, number 8 is from chapter 8. There is a margin of error. Actually, the confidence interval has a form, is a point to estimate the sample mean. It's a plus and minus a critical value times the sigma over square root of n, right? Actually the second term is including the critical value and the standard deviation, right? That was the margin of error. So now the second part is the 2.1. Can you see the point to estimate the sample mean? Yes, in part B, the sample mean was given. It's a 45.1. So it's actually the confidence interval that would be 45.1 in the middle. Yep, in the middle. The point estimate, the sample mean, and plus and minus the margin of error. Actually the textbook is using the notation is just E. Just E was the margin of error. So I think the correct the demonstration of the confidence interval, that is the choice C, because we have the middle point, right? It must be 45.1. I think 45.5 is a closer one, so I think the choice B is the better than C, because in the middle there must be 45.1, the sample mean. Let me check the answer. On the next page there is the answers. Where is the next page? Yes, here. Yeah, the answer is the B. Yeah, the B is better. Even though the illustration is the same, is correctly as here, but the value in the middle, that must be the sample mean, which was the 45.1. Okay, and then now the length must be is a twice E, because this way this way the E, and that is the another E. So the length, the length is must be is the 2 E's, right? So twice the E was the 2.1. So simply 2 times 2.1. So the length will be 4.2. Does it make sense? Yeah, here's the answer. It's 4.2. And the confidence interval, then you can subtraction first, and the addition is next. Then you can take the two scores, right? And the choice B is the best, the illustration of the confidence interval. So you can try the number 8. And now I'm trying to number 10. Actually this homework from chapter 7 and chapter 8. Next time, tomorrow, I will review the second homework. The second review homework is tomorrow, which was from chapter 9. But this homework is from chapter 7, sampling distribution of the sample mean, and chapter 8, the confidence interval. Okay, so now in number 10 is actually we construct the 95% is confidence interval is here. Yeah, so let me give you the formula again. The formula is the very first we just plug the sample mean as a point estimate, and we have a sigma. So we need the z-score as a critical value and plug the sigma over square root of n. So x bar is a 23, x bar is a 23 plus n minus, and the z-score for 95% is 1.960. Can you remember the map, the table, right? Here is a confidence level, it's a 90%, 95%, and 99% is most common confidence levels. Then the critical values, the z-score was 1.645 and 1.960 and 2.575. And now we have a 95%. So the critical value, the z-score, it should be 1.96. And continuously is a plug, the sigma was 3, and square root of the sample size is 33. So let me keep the point estimate, the sample mean 23, and the margin of error, the second part will be 1.96 times 3 over square root of 33. I have a 1.024. How many decimals? It's a 1 decimal places. Okay, that is enough. So you can take the subtraction first here and addition the second one. That is the 95% is a confidence interval. Yep. Here is the margin of error, the second term. Yep, the second one, that is E, the margin of error. And it asks us what is the critical value, which was 1.960, right? Yep. So you can answer the other parts. Okay, so now maybe the next page has the answers. I think it's maybe here, right? Yep. Can you see that? It's the z-score 1.960. Yep. So you can try to make the 95% is confidence interval in the question number 10 when sigma is known. In chapter 8, we have another topic when the second topic was when sigma is unknown. When sigma was known, right, then we use the z-score. But unknown, we have to use the t-score as a critical value. So let me go to the next problem. It's a number, I think, yes, it's number 17. It's a number 17. The identify the margin of error, the formula for the margin of error when the population standard deviation is actually the population standard deviation is a sigma unknown, right? So here's the answer, the D, right? So now we can modify the formula. When sigma is known, the formula was using the z-score and the sigma because the sigma was known. But now when sigma is unknown, but the point estimate, the sample mean, but we have to use the t times s over square root of n. So look at this one. The second part, the margin of error, is actually it is. And who is the s? That is the sample standard deviation. Who was the sigma? Sigma was a population, the standard deviation, right? So that is the big difference. And we have two topics. So now we are going to have a sample standard deviation instead of the population standard deviation because now the sigma is unknown. So because of that, we are going to take the t-score from the t-table. Okay, so let me try the next example, maybe number 18 somewhere. Where is the number 18? I think here is a number 18. It will be the last topic today. Chapter 8. Okay, let's see here. Let me see. Yep, T interval is a T interval procedures. Here's a mean, sample size, and the S, the population standard deviation, and here is a 99% is confidence level. So now it was the formula is x bar plus n minus the t-score times s over square root of n. So the others is no problem. I just plug the 34 for the sample mean, and we are going to take the confidence interval, the t-scores later, and plug the s was given 3, and the sample size was given is 25. Everything is the same, except the t-score, except the critical value, right? So now we have to take the critical value, the t-score from the t-table. Here's a t-table. Okay, it's good. Can I? Yeah. Yeah. It looks smaller, but I need the t-tables is together. This one and this one is together. Okay. To take the t-score, we need the degree of freedom. It's actually the degree of freedom is n-1. So the n was 25. So degree of freedom will be 25 is -1. That will be 24. So we have to go to the degree of freedom is 24, right? Yeah, here's a 24. So we have to choose is one of them from the line with the degree of freedom 24, which was n-1. And now is another one. It depends on the confidence level again. So at the end, just a second. Yes. It's not really. This t-table is a little bit different. It's a little bit different, the t-table I gave you. When I gave you, the t-table I gave you is better than this one because the t-table I gave you, there is the confidence levels is at the bottom, right? So I remember the first one is the 80%. The very first one was the 80%. And the next one, it must be, just a second. I have to make this bigger. And the next one must be 90%. and 95%, and 98%, and 99%, right? So when you are doing the homework or take the exam, please print out my t-table. The t-table I emailed you. That is better. So now we had how much confidence level? As a confidence level was is 99%, right? So it's not only depends on the degree of freedom, it's actually now the degree of freedom was 24, and the confidence level is 99%, right? So we have to choose a t-score 2.797. So let me plug 2.797 as a critical value for the confidence interval. Okay, so you can finish to make the confidence interval from the subtraction to the addition. Yeah, that is the confidence interval. And the second part, I mean this one, that is a new margin of error using the t-score from the t-table. Depends on the degree of freedom and the confidence level. Okay, so now I can summarize. This homework has two chapters. It's a chapter 7 and chapter 8. And actually the chapter 7 is the sampling distribution for the sample mean. And the chapter 8 is a confidence interval for unknown population mean. And actually it has the two topics. It's using the Z, using the T. When sigma is known, is unknown, right? So it is the review homework. The first review homework is from chapter 7 and chapter 8. Okay, so please finish this one. And as already I posted the second one, and I will give you the discuss about the second review is tomorrow. If you have any question, please email me. And if you have any problem, I mean the rounding problem, is email me also as well.